Let's take a look at determining how costs behave. We'll focus on cost functions, and a cost function is a mathematical representation of how a cost changes with regard to changes in the level of an activity relating to that cost. Let's go over a little bit of terminology. Variable costs are the costs that change in total relation to some chosen activity or output, while fixed costs don't change in total relation to an activity or output. It remains the same. And a mixed cost or mixed cost are those that have elements of both fixed and variable components, and sometimes this is also called a semi-variable cost. Let's go over some assumptions. The first assumption I want to tackle is that variations in the level of a single activity, the cost driver, will explain the variations in the related total cost. So we assume we have only one activity, the cost driver, causing variations in total costs. And then we also assume that cost behavior is approximated by a linear cost function within the relevant range. So graphically, the total cost versus the level of a single activity related to that cost will appear as a straight line within the relevant range. Okay, let's talk a little bit about how accountants will define the terms versus those studying statistics. Accounting will call it a variable cost, and statistics will refer to that as the slope or the slope of the line. The fixed cost is that element where the line crosses the y-axis. In statistics, that's referred to as the intercept. And a mixed cost is one in statistics that would be called a linear cost function. Now, the linear cost function is usually given by the formula y equals a plus bx or y equals mx plus b. I've seen both used in practice. Y stands for the dependent variable. It's what we're trying to predict. A represents the intercept. And when we graph it, that appears as fixed cost. And then B represents the slope of the line, so that's the variable cost per unit, and X is the independent variable, which in our language is the cost driver. Alright, so let's say we have a total cost function that's equal to $10,000. This is a fixed cost because it appears as a horizontal line. It doesn't change regardless of the level of activity. Now let's take a look at a variable cost function. A variable cost function, in this case, appears as an upward slope, which is typically what we find with cost functions, because it says as we add more and more activities, the cost per unit remains the same, but the total cost goes up. So in this case, every instance of whatever that independent variable x is, we incur an extra $5 per unit, and we have an upward slope. Okay, when we combine both cost functions, what we see is that the intercept crosses above the 0 point, and that represents the fixed cost, and in this graph it's at $10,000, and then it slopes upward as we move up, representing variable costs. Okay, so if we combine variable cost, which is the blue line, with the fixed cost, which is the magenta line, what we wind up is the yellow line, which represents the total cost function, and in this case our cost function is estimated as y equals 10,000 plus $5 per unit of x. Alright, so let's talk a little bit about how we would classify variable and fixed costs. Alright, first we need to consider the choice of the cost object. So different cost objects may result in different classifications of the same cost. The second aspect we need to think about is the time horizon. The longer the period, the more likely cost will be variable. Another way of saying that is in very short time horizons, there's very little we can do to change cost. In very short relevant ranges, very short areas that we can affect things, costs behave, many more costs behave in a fixed manner. Okay, and relevant range is the idea that we can predict behavior only within some band of activity. Maybe that is plant cost for the next year, plant cost for the next month. But we're not considering large variations such as building a new plant, which maybe would take a whole year, and then of course our cost structure could change sizably. Okay, you want to look for cause and effect as it relates to cost driver. The most important issue is determining whether we do get a cause and effect relationship between the level of an activity and the cost related to that level of activity. Now, we might get a cause and effect relationship if we uncover a physical relationship between the level of activity and costs, or perhaps a contractual agreement, and we may even see one through knowledge of our operations. An example of a physical relationship would be we're looking for dollar amount of labor versus number of employees we have. Well, as we physically hire and bring in more employees, we can expect the dollar cost of labor to go up. Now, on the other hand, a union agreement may stipulate a contractual agreement. If we read the agreement, we may determine a cause and effect from that agreement. Now, a high correlation between activity and cost doesn't necessarily mean that there's causality, so that's just something to keep in mind. Let's talk about different ways, different methods of estimating cost. There's the industrial engineering method, the conference method, an account analysis method, quantitative analysis method, and a simple approach is the high-low method. A more advanced approach is the regression analysis. When we're talking about the industrial engineering method, this is the idea that we estimate cost functions by looking at and analyzing the relationship between inputs and outputs in physical terms. So it may include time and motion studies. It's very thorough and detailed, but it's also costly and time consuming. An example of this has to do with how much material is used in a production process. There may be strong analysis performed to figure out how much the yield will be, how much waste will be, and then if we estimate the cost of materials based on the volume we use, we could get a very accurate measurement of what we would need given a prediction of activity. Okay, sometimes this is called the work measurement method as well. And industrial engineering methods are often used to determine how much labor is required, not only materials, in a manufacturing setting, of course. Though we certainly can use cost estimation in non-manufacturing settings. All right, let's talk a little bit about the conference method. Conference method says, let's estimate cost functions on the basis of analysis and opinions about cost and their drivers gathered from various experts within a company or departments within a company. So we pool the expert knowledge, and from that, and based on the reliance of opinions, we come up with a method of what the variable costs are and what the fixed costs are. And this is still a subjective method. But I have seen this in practice, and it's used by many companies. Now, the account analysis method is very common. Here, estimates of cost functions are made by classifying cost accounts as variable, fixed, or mixed with respect to the identified level of activity. So what we do is we take a look at the general ledger, and then we make a determination based on some analysis of the account, or maybe the accountant's perspective, or maybe an analyst's perspective, and we determine which ones are fixed, which ones are variable, and perhaps which ones are, say, 40% fixed and 60% variable. Okay, it can be reasonably accurate, cost and effective, and easy to use, but certainly it's subjective. I will tell you that in my experience, this is the most common method I've seen used. Okay, but you could take advantage of qualitative analysis, and here we use a formal mathematical model to fit a cost to past data observations, and then rely on that to build a predictive model of costs. Now, the advantage is that the results are objective. All right, let's go through some steps in estimating a cost function using a quantitative analysis. Here's what you do. You choose the dependent variable, in other words, what is it that we're trying to predict. Then we identify an independent variable or cost driver. In other words, what level of activity can we use to help determine what our cost level will be if we can make an estimate of what the independent variable would be. Then we can collect data on the dependent variable and the independent variable or the cost driver. We can plot the data and estimate a cost function using a variety of methods, and this slide represents two of those methods. You could use the high-low method or regression analysis. Once we do that, we evaluate the cost driver of the estimated cost function. Okay, let's cover the high-low method briefly. It's the simplest method of quantitative analysis. It certainly was more common long before we had desktop spreadsheets and cheap computing power. Okay, what we do is we use only the highest and the lowest observed values. So we would calculate a variable cost per unit of activity using only the high and low method. And here's how we would do it. You would take the cost associated with the highest level of activity, subtract the cost associated with the lowest level of activity, and then divide the difference in cost by the difference in activity levels, and that will calculate a variable cost per unit of activity. Okay, then we calculate total fixed cost by taking the total cost from either the highest or the lowest activity level and subtract the variable cost unit of activity that we already calculated times the activity associated with the above cost and divide it by the fixed costs. And then we would summarize what we've found by writing a linear equation. And we would come up with the dependent variable, or y, will be equal to the fixed cost plus the variable cost per unit of activity times the activity. Now let's briefly cover regression analysis. Now, regression analysis is a statistical method, and it measures the average amount of change in a dependent variable associated with a unit change in one or more independent variables. It's certainly more accurate than the high-low method, and it's because it uses the regression equation to estimate cost using information from all of the observations, while the high-low method only uses two observations, the high and the low. Now, there's simple linear regression, where we only consider one independent variable to predict the dependent variable, and there's multiple linear regression, or multiple regression, where we try to estimate the relationship between the dependent variables, and we could use two or more independent variables. Goodness of fit is the idea that explains how well the relationship explains the fit between the cost driver and the costs. The residual term measures the distance between the actual cost and the estimated cost, or predicted cost. Okay, let's talk a little bit about criteria for evaluating alternative cost drivers. Economic plausibility is one, goodness of fit, the significance of the independent variable is a third. Now let's talk just briefly about nonlinear cost functions. Sometimes we see nonlinear cost functions resulting from economies of scale, and this is the idea that says we can get better output as a result of increasing the scale of our operation or the size of our operation. And when that happens, cost won't behave linearly. Instead, what we'll see is huge improvements as we add more and more units, but then we reach a point where as we add more and more units, we get smaller improvements. Lots of times